You are welcome back to my class. We are still on balancing of ionic reaction. Balancing of ionic reaction. In my last video, I've explained how to balance simple ionic reaction. Simple ionic reaction. So in today's class, we are going to learn how to balance complex ionic reaction. Balancing of complex ionic reaction. So a complex ionic reaction or equation can be balanced in two ways. It can be balanced in an acidic medium, then it can be balanced in an alkaline medium. So in this video, we are going to look at balancing of complex ionic reaction in an acidic medium. Balancing of complex ionic reaction in an acidic medium. Then I'm going to use two methods to explain balancing of complex reaction in an acidic medium. We are going to balance by using oxidation number method. Then we are going to balance by using ion electron method. Ion electron method. So let's start with the use of oxidation number method. Oxidation number method. So we want to balance in what? In an acidic medium. In an acidic medium. Reaction between Fe2 plus MnO4 minus gives Fe3 plus Mn2 plus. So what is the first step to take? What is the first step to take when you are using oxidation number method? When you are using oxidation number method. So the first step to take is to assign oxidation number. You assign oxidation number to each atom. You assign oxidation number to each atom that has changed in the reaction. Assign oxidation number to each atom that has changed in the reaction. We have iron 2 plus, which changed to iron 3. Then from this one, we have MnO4 to Mn2 plus. It shows that it is only manganese. It is only manganese, that is Mn, that changed in this reaction, not MnO4. Only manganese change. So for this one now, what will be the oxidation number of Fe? That is the charge on it. So the charge on it is +2. Now from here, we are going to calculate the oxidation number of Mn out of MnO4. We calculate the oxidation number of Mn out of MnO4 because it is only Mn that changed in the reaction. Only Mn that changed in the reaction. So we look for Mn. So Mn is our unknown. Mn is our unknown. That is manganese is our unknown. So the charge on oxygen, that's MnO4 equal to -1. You bring that -1 to the front of equal to. So you assign oxidation number. You assign oxidation number to oxygen. The charge on oxygen is -2. Then you are looking for this one. So you don't assign oxidation number to the atom that you are looking for. So this atom is our unknown now. That is Mn. So the oxidation number of oxygen is -2. So -2 times 4 oxygen will give us -8 equal to -1. So Mn will now be equal to -1. By the time you bring this -8 down here, we change to +8. So -1 plus 8 will give us +7. So which shows that the oxidation number of manganese Mn from MnO4 is +7. So the oxidation number of Fe here is +3. That is the charge on it. While the oxidation number of Mn here is what? Is +2. So that is the first step to take. Now the second step now, you balance each atom. You balance each atom that present in the reaction. Balance each atom that present in the reaction. So the number of atoms do not have anything to do with the number of charges. So when you are balancing the number of atoms, you don't count the number of their charges. You don't count the number of their charges when you are balancing the number of atoms. Now, the first atom here is Fe, that's iron. So the coefficient here is 1. So the subscript here is 1. So you don't count the number of charge when you are counting the number of atoms. So 1 times 1, that is Fe. We have 1 atom of Fe. Then at this side too, The coefficient is 1. The subscript is 1. That is what is at the base is 1, invisible 1. So 1 times 1 will give us Fe. So we have 1 atom of Fe at this side. Now at this side we have 1 Mn. 1 atom of Mn at this side. Then we have 1 atom of Mn at this side, because we are not counting the number of charge. We are not counting the number of charge. So which shows that our equation is what? Is balanced. Our equation is, so the number of atoms is balanced. Now the next step to take is to balance the number of electron loss and the number of electron gain. You balance the number of electron loss and the number of electron gain. Then don't forget that when you are using oxidation number method, you don't split your reaction into half oxidation and half reduction. No, you don't split your reaction into half oxidation and reduction. So the next stage now, we balance the number of what? We balance our oxidation number. So which accounts for the number of electron loss and the number of electron gain. So for Fe, oxidation number of Fe equal to, that is what you have at the product side, your oxidation number at the product side minus the oxidation number at the reactant side. So this is plus 3 at the product side minus the reactant side minus plus 2, which is equal to plus 3 plus times minus will give us minus 2. So equal to plus 1. So there is what? There is loss of 1 electron. Loss of 1 electron. There is loss of 1 electron. Don't forget that those one with positive ion, they are electron giver, which leads to what? Loss of electron. So there is loss of 1 electron. So it shows that ion 2 to ion 3, ion 2 oxidize to ion 3. So the next one is manganese. The oxidation number of manganese from the reactant, from the product side is plus 2. So product side minus the reactant side minus plus 7. So which is equal to plus 2. Plus times minus will give us minus what? Minus 7, which is equal to minus 5. So there is what? Gain of 5 electrons. Negative gain electron, while positive lose electron. So there is what? Gain of 5 electrons. There is gain of 5 electrons. So we use the number of electron from the first reaction, or from the first particle, to multiply the number of electron from the second particle. Then we use the number of electron from the second particle to multiply the number of electron from the first particle. That is the coefficient of electron here. The coefficient of electron here, that is this 5, we are going to use it to multiply the first one. Then the coefficient of this one here, this one, we use it to multiply that of manganese. So you use 5, the coefficient here, to multiply the one up. You use the coefficient here to multiply the one down. So it shows that in your reaction now, you use 5 to multiply Fe. You use 5 to multiply Fe. Wherever you see Fe in your reaction, you multiply by 5. Then wherever you see Mn, that is manganese, in your reaction, you multiply by 1. So let's do that. So we multiply Fe by 5. We multiply Fe by 5 from this our equation now. So 5 times Fe will give us 5Fe. 2 plus. So you only multiply that 5 by your coefficient. Your coefficient here is 1. So 1 times 5 will give us 5Fe2 plus. Then plus, then you multiply Mn. Wherever you see Mn, you multiply by 1. Mn, you multiply by 1. So 1 times this coefficient here is 1. 1 times 1 will give us 1. That's MnO4 minus. Equal to, then we multiply Fe by 5. Don't forget, wherever we see Fe, we multiply by 5. So at the product side, there is Fe. So the coefficient is 1. 1 times 5 will give us 5Fe3 plus. then plus, we multiply Mn by 1. So 1 times the coefficient, 1 times 1 will give us 1. That's Mn2 plus. Mn2 plus. So we have balanced what? The number of electron at both sides. So we have balanced the number of electron loss and the number of electron gain. So the next stage now, there is something at the reactant side that is not at the product side. That is oxygen. So we have oxygen atoms at the reactant side. Then there is no oxygen at the product side. There is no oxygen at the product side. Then what is acid? Don't forget, we are balancing in what? In an acidic medium. Then an acid is a substance which produces hydrogen ion as the only positive ion when it dissolves in what? In water. So we are going to balance what? Oxygen by adding water molecule. So if you want to balance the number of oxygen at this side, you add water. So the number of oxygen at this side will determine the number of water molecule that you are going to add to this side. So you balance oxygen atoms with water. Now 4 oxygen atoms at this side, I will add 4 water molecules. I will add 4 molecules of water. So I've added 4 oxygen atoms. 4 times 1 will give me 4. So oxygen balance. Now, during the process of adding water or oxygen atom, I've added hydrogen. Then there is no hydrogen at this side. There is no hydrogen at this side. So I've added hydrogen to this side now during the process of adding what? Oxygen. So therefore, we balance this what? This side with hydrogen ion. We balance this side with hydrogen ion. So how many hydrogen do we have at the product side? 4 times 2. That is 8. Will be the number of hydrogen ion that we are going to add to this side. So let's add hydrogen ion to this side. Then our equation will now be 5Fe 2 plus MnO4 minus 4 times 2 hydrogen, that is 8. So you add 8 hydrogen ion. You add 8 hydrogen ion to this side. Then equal to what we have at the product side now. That's 5Fe3 plus Mn2 plus 4H2O. 4H2O. So our equation is balanced. Our equation is balanced. So let's check. Let's check on the number of what? Of charges. So at this side we have plus 2 times the coefficient. Plus 2 times 5 will give us plus 10. Plus 10. So the charge on this one is minus 1 times the coefficient, that is minus 1. The coefficient here is 1. 1 times minus 1 will give us minus 1. Then plus, the coefficient here is plus. Plus 1 times 8 will give us plus 8. So at this side, plus 3 times 5 will give us plus 15. Plus 15. Then this side, the charge on it is plus 2. The coefficient is 1. 1 times plus 2 will give us plus 2. Then plus, this is a molecule. Water is a molecule. Water molecule. So oxidation number of any molecule or a free atom equal to 0. So the oxidation number of water equal to 0. 0 times 4 will give us 0. So plus 8 plus 10 will give us plus 17. So plus 17 minus 1. Plus 8 plus 10 will give us plus 18. So plus 18 minus 1 will give us plus 17 at this side. Equal to 15 plus 2 will give us plus 17. So plus 17 plus 0 will give us plus 17. So our equation is what? Is balanced. So the number of what? Charges at both sides is balanced. So our equation is balanced. This is how to balance complex ionic reaction in an acidic medium using oxidation number. Balancing of complex ionic reaction using what? Using oxidation number in an acidic medium using oxidation number. So let's take example 2. So I'm going to use ion electron method. I'm going to use ion electron method to balance example 2. want to use ion electron method. Ion electron method for example 2. For example 2. So let's take example 2. Reaction between MnO4 minus then plus SO2, which gives Mn2 plus SO4 2 minus. So we want to balance in an acidic medium by using what? Ion electron method. Then don't forget that ion electron method involves the use of what? It involves splitting of what? Redox reaction. It involves splitting of what? Of redox reaction. Now, but before we split our redox reaction into oxidation half and reduction half, so we have to assign what? Oxidation number to each atom that has changed. So we have to assign oxidation number to each atom that has changed. Now, when we look at MnO4 to Mn2 plus, only manganese change from this what? From MnO4 to what? Mn2 plus. So it shows that we only what? Calculate out the oxidation number of manganese from MnO4 minus. So let's look for the oxidation number of manganese. That is MnO4. Then the minus on it will be equal to -1. You bring this minus here. The minus here is the same thing as -1. Then the charge on oxygen is 2 minus. So you don't assign charge with your unknown. So you are looking for Mn. You don't assign charge with Mn. So Mn minus 2 times 4 will give us -8 equal to -1. Then Mn will now be equal to -1. Bring this minus here will give us +8 equal to -1 plus 8 will give us +7. So the oxidation number of manganese from this MnO4 is what? Is +7. So while that of manganese here is +2, that is the charge on it is the oxidation number. So let's come to this side. We are going to calculate the oxidation number of what? Of sulfur. Yeah? Then we calculate the oxidation number of sulfur at this side. Then SO4. Let's look at this. SO2. SO2 is a molecule. It is a molecule. Then we can say that the oxidation number is what? Equal to 0. The oxidation number equal to 0. While the oxidation number of this one is what? The charge on it. The charge on it, which is what? -2. Which is -2. So it is not necessary to calculate the oxidation number of what? Of sulfur out of this place. So the oxidation number of what? SO2 is 0 because it is a molecule, while this one is what? Is -2. This one is -2. Now the next stage now, we are going to split our reaction into half oxidation and half reduction. We are going to split our reaction into half oxidation and half reduction. So which one oxidized? Which one reduced? From +7 to +2. From +7 to +2. That is decrease in oxidation number. Decrease in oxidation number. So we are going to calculate the oxidation. This one is +7. So we are going to calculate the oxidation number of manganese because only manganese changed from MnO4 from this reaction. Now only Mn changed to Mn2 plus. So it shows that it is the only oxidation number of manganese that we are going to calculate out of this MnO4. We are going to calculate the oxidation number of manganese. Now our manganese from this one will be unknown. That's Mn. Then O4. The minus will come to the front of equal to, that is this minus is -1. Then Mn, the charge on oxygen is 2 minus. So minus 2 times 4 will give us minus 8 equal to minus 1. Then Mn equal to minus 1 plus 8, which is equal to minus 1 plus 8 will give us plus 7. So the oxidation number of manganese from MnO4 is what? Is plus 7. So why the oxidation number of manganese at this side is the charge on it, which is plus 2. So let's proceed to the second substance. The second substance, only sulfur change from, this is sulfur 4 oxide, then to which sulfur? So what is the oxidation number of sulfur from this SO2? What is the oxidation number of sulfur from this SO4? So let's calculate the oxidation number of sulfur. That's S and what? And O2. We are looking for what? S. You don't assign what? The charge. You don't assign any charge. Then you assign charge to what? To oxygen, which is 2 minus. That will be S minus 2 times 2 will give us minus 4 equal to 0. Then S equal to, this minus 4 bring it here will give you plus 4. So this is plus 4. This is plus 4. Then at this side, we are going to calculate S from this SO42 minus. So SO4, the 2 minus will come to the front of equal to minus 2. Then we assign charge to what? To oxygen, since we are looking for S. So that will be S. So the charge on oxygen is minus 2. Minus 2 times 4 will give us minus 8 equal to minus 2. Then S equal to minus 2. Bring 8 here, we change to plus 8 equal to plus 6. So the oxidation number of sulfur from SO42 minus is what? Is plus 6. Now, the next step to take is to separate our reaction into half oxidation and half reduction. To separate into half oxidation and half reduction. Then let's look at it from MnO4 to MnO2. From MnO4 to Mn2 plus. So there is decrease from plus 7 to plus 2. There is decrease in what? In oxidation number. This is reduction. This is reduction. So from plus 4 to plus 6, there is increase in what? In oxidation number. So therefore, this is what? Oxidation. So we can separate into two half reaction now. So the first one is what? Half oxidation, then the half reduction. This one is for reduction from oxidation half. Oxidation half. That is from MnO4 minus 2 Mn2 plus. From MnO4 minus 2 Mn2 plus. Then reduction half. Reduction half. This is this is reduction half. Reduction from MnO4 to Mn2 is reduction half. While from SO2 to SO4 is oxidation half. Oxidation half. So oxidation half is from SO2 to SO42 minus. SO2 to SO42 minus. So the next stage now, you balance each half reaction. Balance the number of atoms in each half reaction, except what? Atoms of oxygen and that of hydrogen. You balance the number of atoms from each half reaction, except the what? The atoms of oxygen and the atoms of hydrogen. So you are not going to, let's leave this oxygen, we only balance manganese. Then the manganese is 1 here. Then manganese is 1 here, balance. How many sulfur here? 1. How many sulfur here? 1. So the next stage now is to balance the number of electron loss. Then before you balance the number of electron loss, and the number of electron gain. So you have to balance the number of what? Of oxygen atom. You balance the number of oxygen atom in each half reaction. So let's look at the reduction half. Reduction half. We have MnO4 minus, which is equivalent to Mn2 plus. Now, there is something here that is not here. There is something here that is not at this side. We have 4 oxygen atoms at this side. Then this side is divisions of oxygen. This side is the divisions of oxygen. So we balance the number of oxygen atom with water molecule. We balance the number of oxygen atom with water molecules. Then let's look at this side. We have 4 oxygen atom, so we add 4 water molecules. So we have 4 molecules of water. So we have balanced 4 oxygen now, but hydrogen has been added to this side. Hydrogen has been added to this side. So we are going to balance what? This side with hydrogen. Now 4 times 2, 8. 8 hydrogen has been added to the product side. So we are going to balance the reactant side with 8 hydrogen ion. With 8 hydrogen ion, because of 8 hydrogen that has been added to the product side. So adding reactant side, we have MnO4 minus plus, you add 8 hydrogen ion, 8H plus, equal to Mn2 plus 4H2O. So we have balanced what? The number of what? The number of hydrogen atoms and oxygen atoms at both sides. So for the second half reaction, which is oxidation half, so let's balance the number of oxygen atoms at this from the second half reaction, that is oxidation half. So for oxidation half, we have SO2, which is equivalent to SO4 2 minus. Then, if you look at this side, we have 2 oxygen at this side. We have 2 oxygen atoms at this side. We have 4 atoms of oxygen at this side. So this side is divisions of 2 oxygen atoms. We need to balance this side with 2 oxygen because we have 2 here, we have 4 here. We have 4. So this one is 2 more than this side. So therefore, we balance the number of oxygen at this side by adding water molecule. So we need 2 oxygen to balance this side. We have to add 2 water molecules to this side. So it will now be SO2 plus, we need 2 oxygen to be equivalent to 4 oxygen at this side. So you add 2 molecules of water because you get your oxygen from water molecule, then equal to SO4 2 minus. Now we have added 2 oxygen now. 2 oxygen plus 2 will give us 4. Then 4 oxygen balance. Then hydrogen atoms has been added to the reactant side. There's no hydrogen at the product side. Now we are going to add hydrogen ion to balance the what? The product side. 2 times 2, 4. 4 hydrogen atoms at the what? At the reactant side. So you add 4 hydrogen ion to the product side. You add 4 hydrogen ion to the product side. So the number of oxygen balanced at both sides, then the number of hydrogen balanced at both sides. So the next thing now is to balance the number of electron from each half reaction. So we balance the number of electron from each half reaction. So from reduction half, we have MnO4 minus, then equal to, this is where we stopped. So this MnO4 minus plus 8H plus equal to Mn2 plus 4H2O. So let's calculate the number of charge. That is the number of charge here must be equal to the number of charge at the product side. So which accounts for the number of electron, either electron loss or the electron gain. So let's look at the number of charge at this side. So the charge on this one is minus times the coefficient 1. Minus 1 times 1 will give us minus 1. Now the charge on this one is plus 1. Plus 1 times 8 will give us plus 8. Now at the product side, the charge on this one is plus 2. Plus 2 times coefficient is plus 2. The coefficient is 1 times plus 2 will give us plus 2. Then the charge on this one is 0 because this is a molecule. It has no charge. So 0 times 4 will give us 0. So at this side now, plus 1, at minus 1 plus 8 will give us plus 7. Then at this side, plus 2 plus 0 will give us plus 2. Plus 2 plus 0 will give us plus 2. So we have more electron at this side than this side. So we have to equalize the number of what? Of electrons at both sides. We have to equalize the number of electrons at both sides. So if I say 7 minus 2, that is 7 electron here. That is product side, electron at the product side, which is plus 2. Then electron at the what? At the reactant side, which is minus plus 7. So it will give me plus 2 minus 7, that is 5. So the number of electron at this side is plus 7, while this one is plus 2. So this one is 5 greater than what we have here. This one is 5, that is 7 minus 2 will give us 5. So this one is 5 more than this side. So we have to equalize the number of electron at this side, at both sides. So the side with more electron, you add that 5 electrons to it. And when you are adding electron, don't forget that you are not adding electron, you are subtracting electron. Because electrons carry what? It carries negative charge. Electron carries negative charge. So when you add electron, if I say plus 5e minus, 5e minus. So minus 1 times 5 will give us minus 5. Minus 5 plus 7 will give me plus 2. So when you add 5 electrons, it's like you are taking 7 electrons. I mean, if you add 5 electrons, it's like you are taking 5 electrons out of what? Away from 7. When you add 5 electrons, you are taking 5 electrons away from 7. So we have to add 5 electrons to this side to equalize the number of electrons at both sides. So it will now give us MnO4 minus plus SH plus 5E minus. 5E minus. So 5 electron minus 7 electron will give us 2. So 2 will be equal to 2. Equal to Mn2 plus 4H2O. So we have balanced the first one. Now let's come to the second half reaction. So we are going to balance oxidation half. And this is where we stopped. So we balance oxidation half. That's SO2 plus 2H2O equal to SO4 2 minus, then plus 4H plus. So let's calculate the number of charge. Let's calculate the number of charges at both sides. So this is a molecule. The number of charge here is equal to 0. Then this is a molecule. 2 times 0 will give us 0. Then at this side, the number of charge here is minus 2. Minus 2 times this coefficient, that is minus 2. The number of charge here is plus 1. Plus 1 times 4 will give us plus 4. Now this one will give us 0 equal to minus 2 plus 4 will give us plus 2. So minus 2 plus 4 will give us plus 2. So we have more number of electrons at the product side than the reactant side. So we have to equalize. The number of electrons. So you minus electron from the side with more number of electron. You add electron from the side with more number of electron. So this one is 2 greater than this one. So it shows that you are going to add 2 electrons to the side with more electron you add 2. 2 minus 0 is 2. So it is 2 greater than this side. So equalize it now. Add 2 electrons to this side. You add 2 electrons to this side. So therefore, our equation will now be SO2 plus 2H2O equal to SO4 2 minus plus 4 hydrogen ion, then plus 2 electron. So plus 2 electron. Now let's check if the number of charge is balanced. Let's check the number of charge. This is a molecule, it has no charge, it's 0. This is a molecule, it has no charge. 0 times 2 will give us 0. So 0 plus 0 will give us 0. So at this side, the charge on this one is minus 2. The coefficient is 1. So minus 2 times 1 will give us minus 2. The charge on this one is plus 1. Plus 1 times 4 will give us plus 4. The charge on the electron is minus 1. Minus 1 times 2 will give us minus 2. So minus 2 plus 4 will give us plus 2. Now plus 2 minus 2 will give us 0. So we have 0 at both sides. So our equation is balanced. Our equation is balanced. Now we come to the final stage. Let's move to the final stage of this reaction. Let's move to the final stage of this reaction. Now, for the first half reaction, that is reduction half. For reduction half, this is our product. For reduction half, so we have MnO4 minus plus 8H plus 5E minus equal to Mn2 plus 4H2O. Then the oxidation half. Then this is where we stopped. So we have SO2 plus 2H2O then equal to SO4 2 minus plus 4H plus 2E minus. Now, the next stage now is to equalize what? The number of electron. We have to equalize the number of electron. The number of electron from oxidation half is 2, while the number of electron from reduction half is 4. So we are going to use the coefficient of electron from reduction half to multiply that oxidation half. Then we use the coefficient of electron here to multiply this one. So we are going to use the coefficient of electron from reduction half to multiply oxidation half. So this one multiplied by 5. So the coefficient of this one, of electron here, to multiply reduction half. So we multiply this one by 2. So we multiply by 2. So let's open our bracket. So 2 times coefficient of this one is 2 MnO4 minus. Now 2 times 8 will give us 16H plus. Then 2 times 5 will give us 10E minus. Then equal to 2 times coefficient 1 here will give us 2 Mn2 plus. Now 2 times coefficient of water here, so 2 times 4 will give us 8 8H2O. Now, let's open the second bracket. So let's open the second bracket. So 5 times coefficient 1 here will give us 5SO2. Then 5 times 2, this coefficient will give us 10H2O. Then which is equal to 5 times this coefficient 1, there is 1 here. 5 times 1 will give us 5SO42 minus. Now 5 times 4 will give us 20. So 20H plus. Now 5 times 2. 5 times 2 will give us 10E minus. So now we have equalized the number of what? Of electron at both sides. We have equalized the number of electrons at both sides. So this electron here, we cancel this electron. Now, we are now going to combine the two half reaction. So the next stage, the final stage, is to combine the two half reaction. So we are going to combine what we have at the reactant side here with what we have at the reactant side here. So we combine the product side here with the product side from the second half reaction. So let's write the final answer. So from this first half reaction, we have 2MnO4 minus plus 16H plus. That is the reactant side, and then plus the reactant side at the second half reaction plus 5SO2 plus 10H2O equal to, then the two product sides, you combine the two product sides. So that is, the first one is 2Mn2 plus 8H2O, then plus 5SO42 minus plus 20H plus 20H plus. So this is the final product. This is the final answer. So that is how to balance complex ionic reaction in an acidic medium. Complex ionic reaction in an acidic medium. So in my next video, I'm going to explain how to balance complex ionic reaction in an alkaline medium. Complex ionic reaction in an alkaline medium. If you like this video, kindly subscribe to Royal Learning channel. Share this video with your friends and comment. See you in my next class. Bye.